Now, you're going to take up one more problem, the problem number 54. A steel bolt of 500 mm square cross-sectional area passes centrally through a copper tube of 1000 mm square cross-sectional area. The tube is 400 mm long and is closed by rigid washers which are fastened by the threads on the steel bolt. The nut is now tightened by 1/4 of a turn. Find the stresses in the bolt and the tube if the pitch of the thread is 4 mm. Take Young's modulus of steel as 2 × 10 to the power of 5 Newton per mm square and Young's modulus of copper as 1 × 10 to the power of 5 Newton per mm square. So the steel bolt, so this is the steel bolt having the cross-sectional area of 500 mm square, and then copper tube is 1000 mm square. So this is the copper tube, which is the hatched portion is a copper tube of 1000 mm square. The tube is 400 mm long and is closed by, these are the rigid washers which are fastened by the threads on the steel bolt. So this is the bolt what we are talking about. The nut is now tightened by 1/4 of a turn. So that means the nut is tightened by 1/4 of a turn. Find the stresses in the bolt and the tube. The pitch of the thread is 4 mm. So how to proceed with this problem? So when the nuts are tightened, the tube, what happens, will be compressed and the rod will be elongated. So that is what is going to happen. So this is the tube. When you tighten the nut, what happens? The tube will going to be get compressed. What happens to the bolt? The bolt will be under tension. So because the length of the bolt, so as this washer comes nearer to this end by tightening the nut. So then what happens? There will be a compression in the copper tube. But what happens to the length of the steel bolt? The length of the steel bolt will be under tensile because the length of the steel, but the rigid plate is coming down. Naturally, the length of the steel, which is in extra, will going to be more. So naturally, it will going to be in elongation. Now, so since no external force have been applied, the compressive load on the tube must be equal to the tensile load on the bolt. So what is the static equilibrium says? PS minus PC will be equal to 0. PS is in this tension and PC is in a compression. So naturally PS minus PC is equal to 0. So what is that? PS is expressed this into sigma S into AS minus sigma C into AC will be equal to 0. So therefore, you transfer this to the right hand side, that is sigma C into AC. So it becomes positive. So that is sigma S into AS will be equal to sigma C into AC. So what is sigma S? So we know area of steel bar, which is 500. So sigma S into 500 will be equal to sigma C into 1000. So sigma S will be equal to 2 times sigma C. Also what we know, the total extension of the bolt plus total compression of the tube will be equal to the total load of the moment of the nut. So what is the total extension of the bolt? Delta LS plus delta LC, that is copper tube. So naturally you will going to get it as delta L, which will be moment of the nut. So what is delta LS? PS into LS by AS into ES will be E plus PC into LC by AC into EC is equal to what is the moment nut? So that means you have a pitch of 4 mm. So what is the pitch of 4 mm? So that means if you rotate once, if you are rotating by 360 degrees, that is the single rotation, then the nut will going to move by 4 mm. So that is the meaning of the pitch. So that means for one rotation, you are going to move by 4 mm. That is, you are converting the rotational motion into translatory motion or to the linear motion. Since the nut is now tightened by 1/4 of the turn, therefore just you have a quarter turn. That means 1/4 into 4, which will be equal to 1 mm. So that will going to be the moment of the nut. So PS by AS is nothing but sigma S into length of the steel bar by Young's modulus of the steel bar plus sigma C, that is length of the copper into length of copper into stress in copper divided by Young's modulus of copper, which is EC equal to 1. So on substitution, what we can do is, we know that sigma S will be equal to 2 times sigma C. Length of the steel bar is 400 by 2 into 10 to the power of 5 plus sigma C into, again the length of the copper will be 400 by 1 into 10 to the power of 5 will be equal to 1. So on simplification, sigma C will be equal to 12.125 Newton per mm square, which is compressive in nature, because as you tighten the nut, what happens? The steel tube, the copper tube will going to get compressed. So naturally it becomes the compression. What happens to the stress induced in the steel board? So sigma S will be equal to 2 times sigma C. You substitute the value of 2 into 125, which will be 250 Newton per mm square, which will be under tensile. So this is how you will be able to solve this particular problem. Now we are going to take up one more problem. That is the problem number 55. A composite bar of steel and brass is fixed between the rigid supports and loaded as shown in the figure. So here we have the steel and brass. So this is the steel bar and this is the brass bar having diameter 20 and having diameter 30. And the length of the steel bar is 400 and the length of the brass bar is 300. Find the stresses and load in each bars. Young's modulus for the steel is 200 into 10 to the power of 3 Newton per mm square, and Young's modulus of brass is 105 into 10 to the power of 3 Newton per mm square. Also find the change in the length of the bar. So here the two ends of the bar have been fixed. One end of the bar is steel having diameter 20 to a length of 400, and the brass bar having diameter 30 for a length of 300 mm. But only one load is applied at the junction, which is 30 kilonewton, which is acting towards the left side. Find the change in length of the each bar. So we know the data, whatever it has to be given, the diameter of the steel bar, which is ds, which is 20 mm. The diameter of the brass bar is 30 mm. The length of steel bar is 400 and the length of brass bar is 300 mm. And the Young's modulus of the steel bar is 200 into 10 to the power of 3. And Young's modulus of brass EB will be equal to 105 into 10 to the power of 3 Newton per mm square. So what is the load applied? The load applied is P, that is 30 kilonewton, which is 30 into 10 to the power of 3 Newton. So this is the free body diagram as the load which is applied in this direction. So since this end is the fixed, so in order to keep the bar in equilibrium condition, so you're going to have one more load which is acting in the opposite direction to this, which will be equal to compressive in nature. Similarly, when you are considering for the brass bar, as the load is applied towards the left side, so naturally in order to keep the body in equilibrium at the point C, you make equal and opposite force which is acting away from the first position. So that will going to be, again it becomes tensile, RC, RA and RC. So if you are considering the free body diagram of this, here RA will be acting like this, so RA will also be like that. So here both are in compressive in nature. So steel bar having diameter 20 for a length of 400 mm. Similarly, when you are compressing for when you are considering from the brass bar, as the brass bar has been, the load is acting towards the right side, which is fixed, which is RC. So since it is to keep it in equilibrium, RC will be also acting in the opposite direction, which becomes tensile. So we have a diameter of 30 on brass bar and a 300 mm length. You have the diameter as 20 for the steel bar and having a length of 400. So this is how you will be able to write the free body diagram. So what will going to be the stress and brass bar, stress in steel and brass bar. The steel bar is under compression and the brass bar is under tension. Naturally, for equilibrium condition, what happens? RA plus RC will be equal to P. Reaction on the steel bar RA. So force or load on the steel bar PS. So reaction of brass bar RB will be equal to the force on the load, force or load on the brass bar, which is B. So that is what we want. RA plus RC will be equal to P. So that, see why we are considering thus A and C here, because this is the condition what we have been applied with A and C. So that is the reason why we are considering that as RA plus RP is equal to P. So what is the reaction on the brass bar? The reactions on the brass bar will be equal to force or load on the brass bar. So that is PS plus PB will be equal to P sigma S into AS plus sigma B into AB will be equal to P is 30 kilonewton, which is 30 into 10 to the power of 3. So sigma S into what is the area of steel bar? The area of steel bar is pi into 20 square by 4 plus sigma B into pi into 30 square by 4. So that will be equal to 30 into 10 to the power of 3. So on simplification, so what happens? Sigma S into 20 square will be plus sigma B into 30 square is equal to 30 into 10 to the power of 3 by 4 in 30 into 10 to the power of 3 into 4 by pi. So on simplification, sigma S into 400 plus sigma B into 900, which will be equal to simplification 38197. So you divide throughout by 10, 4 into sigma S plus 9 into sigma B will be equal to 382. So also compression on the steel bar will be equal to elongation of the brass bar. So here delta LS will be equal to delta LB. So you have PS into LS by AS into ES will be equal to PB into LB by AB into EB. So we know that PSAS is nothing but PS by AS is nothing but sigma S into LS by ES is equal to sigma B into LB by EB. So sigma S into length of the steel bar is 400 divided by Young's modulus is 200 into 10 to the power of 3, which is equal to sigma B into length of brass bar is 300 divided by 105 into 10 to the power of 3. So on simplification, sigma B will be equal to 0.7 sigma S. So you substitute that in the value of sigma B. 4 into sigma S plus 9 into sigma B is nothing but 0.7 into sigma S will be equal to 382. Therefore, stress in the steel bar, which is sigma S, will be equal to 37.1 Newton per mm square, which is the cross section. Similarly, stress in the brass bar, which is 0.7 into sigma S. So you multiply that 37.1 into 0.7, which will be on simplification. You will going to get it as 26 Newton per mm square. So what is the load on each bar? The load on each bar is PS will be equal to sigma S into AS. So sigma S is 37.1 into AS is pi by 4 into 20 square will be equal to 116,553, that is 11,655.3 Newton, which will be equal to 11.6 kilonewton, which is compressive load. Similarly, load taken by the brass bar, which is PB, will be equal to sigma B into AB, which is equal to 26 into 30 into 30 pi into 30 square by 4. On simplification, 183. So 18,378.3 Newton, which will be equal to 18.6 kilonewton. So similarly, we have the change in length. So what is the change in length? Change in length of the steel bar will be equal to delta LS will be equal to PS into LS by AS into ES, which is nothing but sigma S into LS by ES, which will be equal to, on substituting these values, sigma S is 37.1 into length of the steel bar is 400 divided by Young's modulus is 200 into 10 to the power of 3. On simplification, you will going to get it as 0.0742 in compression. Similarly, the change in the brass bar, which is delta LB, again delta LS is equal to delta LB, so you will going to get it at the same value as that steel bar, which is 0.0742 mm tensile, and delta LS will be equal to delta LB. That is the reason why. So this is how you will be able to solve this particular problems. So if you find this video is useful, please subscribe to my channel.